Now we go to discuss butter oil. Butter oil is actually milk fat. Nó gọi là dầu bơ. It's a fat from milk. And then if we go to the next process, if we make it of higher purity, then we have a product called anhydrous milk fat, which means that the milk fat without water. Anhydrous with no water. How to process it? So we have two methods to make, methods 1 and methods 2. And methods 2 is actually the conventional. This is conventional method. Means that from raw milk we make cream, and from cream we make butter. We already discussed up to here, right? From cream to butter we have a byproduct which is called buttermilk. And now to make butter oil we have to melt. We do the melting. We melt the butter and we hold it for a while for the fats to get melted completely, and then we do centrifuge. When the fat is melted, become liquid, we do centrifugation so we can separate almost here the butter oil has almost 100% of fat already, and then this is the byproduct. So if you remember, butter contains around 80% of fat, and now butter oil contains almost 100% of fat. So that the 16% or almost 20% of water here will become the byproduct, right? We remove the water phase, and then this byproduct is called butter serum. And this byproduct is also very rich in polylipids, in the lipids from milk fat globule membranes. And now we can do a further treatment to have AMF, vacuum treatment at high temperature. We increase to high temperature, we reduce the pressure, so the component which can evaporate now evaporate. Like the water, we evaporate. Some other flavor component will evaporate. And then we have here, like you see, AMF, which is very purified in fat content. And on the left side, this is a new method to make butter oil or to make AMF without the need to go to make butter first. Conventionally, we make butter first and then we go further, but for the new methods, we don't need to make butter. So the cream here at 40% of fat. Now we do further centrifugation to have the cream of higher fat content, 75% of fat content. And then the next step will be homogenization using a homogenizer. When we homogenize it, and then we have phase conversion by homogenization, and then after that we centrifuge. We do the centrifugation like the same here. When we centrifuge, we can separate the lighter phase. Lighter phase is butter oil. The heavier phase is a byproduct. And here, when we centrifuge the cream of 40% of fat to the cream of 75% of fat, means around 35% of water phase is removed. So this is the byproduct. And here they call this name, the name is cream residue 1. And actually this is the name. Either they put the bracket here buttermilk, but it's not the same at the buttermilk this side, at the right side, okay, not the same. So they call this, some people call it cream residue 1. And then here from the cream, they do homogenization, centrifugation to separate the oil phase, and the water phase is removed here as a byproduct, and then they also they can name it cream residue 2, something like that. So if you hear about residue 1, residue 2, then it would be like this. And here from butter oil to AMF, they just apply the same. Now we have an important question here. If we study in chapter 6, homogenization is to reduce the fat globule size from the large size to smaller size, right? But here, homogenization is actually not to reduce the size, but to break it up everything, to even like break all the fat globule and the fat will come together, will just separate away, separate in a layers actually before centrifugation. The question is why? Why homogenization here doesn't reduce the size, but break up all the fat globules and release the fat phase? Because we study in chapter 6, if you remember, there are several parameters of homogenization. And one of the important parameter is the ratio of fat and surface active material. This cream has a lot of fat, so when we do homogenization, we increase a lot of surface area, and because it contains too much fat, that not enough the proteins, not enough the caseins, enough the surface active material to cover the membrane. So then, because they are not covered, then they come together. So normally in normal homogenization, the membrane is covered with casein, but now in this case it's not enough casein to cover, so the fat small droplets will just clump up together, come together, and then fill with each other, and then it's become like a mat of oil of fat actually, right? So the answer here is because there is not enough surface active material. This is just an illustration. You see here in milk, the fat globules are intact. Now we do centrifugation to have cream. Cream means now we have more fat globules. When we do churning, we break the fat globules, we obtain butter, and the byproduct buttermilk. The buttermilk is the water phase from the cream, but it has broken pieces of fat globule membrane of MFGM. That's why it contains quite amount of polar lipid, right? From butter, we do melting and concentration, then we can separate. Now we have the oil, butter oil, and this is butter serum. Similar like buttermilk, but now it has even more broken pieces of MFGM, so even higher polar lipid. On the left side, now we do further concentration, then we have the cream of higher fat, now even more fat globules. Even more fat globules, then when we do homogenization to have phase inversion, so then we just break all the fat globule actually. Now the phase here is become fat, not water anymore. And then we can just separate by centrifugation. We have oil, butter oil, and we have cream residue too. Now we talk a little bit about AMF, anhydrous milk fat. AMF is actually milk fat. So we already discussed in chapter 2 that actually chapter 3, milk fat is kind of saturated fat because it's from animal, it's not from plant, right? So they can apply milk fat in bakery instead of using hydrogenated vegetable or fish oils. If they use vegetable oils, if they use fish oil, then they do hydrogenation to make it saturated, to make it hard. It's hard fat, hard shortening, to be used in bakery, to be used in instant noodle, for example. But this is not natural because we have to apply the chemical process. Here then we can use a milk fat which is quite solid, which is quite hot already, so it's more natural to in bakery, in other products, confectionery, and then in making, recombining butter, for example. Normally, to make butter, we start from milk to cream and to butter. But in industry, you can make butter backward from AMF. Okay. From AMF, we have to do emulsification, so we need to add some emulsifier. Right, and the product is stable at room temperature. Why stable? AMF has almost 0% of water, means that the water activity is very low. Very low means no microorganism can grow. But however, the oxidation can still occur. The oxidation of fat can still occur. So it's also better to put in a fridge or to do the packaging without the presence of oxygen. Now we talk a little bit on ghee. Ghee is just similar product like butter oil, but the way of processing is somehow different. Ghee is clarified butter. It's from the butter, they cook it. Traditionally, they just cook it for a long time at high temperature. So almost all the water will evaporate away. The protein will be denatured and deposit, precipitate, and then they can remove. That is why they call clarify butter. They make it clearer by removing water, by removing other dry matter components like proteins. And because of the high cooking and intense cooking like that, the flavor is strong, strong buttery flavor. And this product is not so healthy. Not so healthy because we heat too much, and for a long time the oxidation already occur, and then this product is not so healthy. But it's nice because people have a long history of using it, they are used to it, and the taste and flavor is familiar. Okay, so but nowadays then they have a new method. They just add some additive instead of doing the long and intensive heat treatment. They just add some additive to have similar flavor. The traditional ghee is more rancid, the fat is more oxidized, the color is kind of dark, the flavor is nutty flavor. The ghee is also a stable product because no microorganism can grow. Okay, so we just done with the third part of chapter 7. Chapter 7, we talk about dairy products, that we have a number of products, but we just finished up to now a half of the chapter. And these are the references for you to read further. This is the important book. And this is the Cosmos from my professor in Belgium. And then I studied there. And this is actually my professor. So you can always look somewhere for the note to read more. Okay.